Welcome everyone. Time to get back at it. Been doing a lot of thinking about this project, and I'm really happy with how it's coming out so far. So I really hope I get a chance to build something like this and actually test it out in real world application and see if anything, if it does what I want it to do. So tonight's episode, I'm looking to see if I can finish up the shaft. One thing I know for sure that I need to do is to get the keyway put in there, and then from there, I want to make sure that what I have here and how it interplays with the rotating blades and giving some thought about the stationary blades. I'm wondering if I will need to modify this piece here to where I can install a bearing. I think that's have it press fit in there so that it won't turn. It'll turn independent of the shaft. I'm still kind of thinking about that, but I think that maybe what to keep the alignment and everything like that. What I could probably do is do a little more research on how blades like this are done from like a steam turbine uh, way they do it. So we'll see how it goes. If I do that, then I'm definitely going to have to, because this hub is the same between both variants, whereas the one in the rotating shaft literally well, actually no, this is different. This is different because the rotating blades have the keyways cut into them. Oh, let me see if I can open that here. Going through that, yeah, have the star in there, or the whatever you want to call that. That connects to the shaft. So if I do any modifications to that, that'll be actually pretty easy to do. So let me start off by, let's grab this bad boy and open it up. No, I don't want to do a feature recognition, so I'm just getting some information here for the keyway. So it looks like that keyway, oh, I need to open up the assembly, not the, I need to go ahead and open up the whole assembly here. There we go. Yeah, because basically that shaft just needs to mimic this. So let me get a dimension here on this. Uh, Gosh, I've been using this thing all day, helping somebody else with the design. All right. 3.175 centimeters. Oh, I need to change that back to inches. Inches, there we go. Okay, 1.25. And how do I have the shaft? How far down does that go? I have it meeting that, so if I do the same cut, that'll be just fine. And I think I have that rotating, which is fine. So what I'm going to look at here is this, and this actually needs to go away. sure it doesn't kill anything else. Yeah, just that. Yeah, that's good. Oh, I also need to know. No, actually, I just need to keep. Oh, wait. No, I need the diameter of that shaft for the internal. Let's see. Let's see if I can grab that information here. Oh, it won't let me measure that. Damn. Oh, there we go. That just gives me a chord length and an arc. Let's see if I can play with it here. It's not letting me sketch. Let's try this. Let's open this up. And we'll go with feature recognition this time. Okay, it didn't recognize anything. That's fine. And it still won't let me do it. I can do it this way. There we go. That's weird. Let's see. That looks... Yep. Alright, what's that information? Copy that. Get out of there. Don't need to save anything. Goodness. I want the shaft. There we go. Let's do that. And I want that circle there. Let's put this dimension on there because I'm thinking I want to go a little bit over that. Let's see, 0.43. .063. Slip fit, and if I have 1/32 of an inch on each side, that should be fine. So let's go ahead and go with a 1/2 inch there. And we're going to go... Honestly, I need this to be a whole feature. I don't know that there's a 2-inch drill. They can lay that out. That would be fine. And we'll go... Let's go... Let's see, I had... Let me look at something. Oh, jeez. We'll do that. We'll cut it. And then we'll take and cut out that keyway. What is that information? What did they do here? I wonder. Oh, they actually made it a little bit smaller so it snugs in. So we'll go a little bit bigger so it slides on, but not too much. I'll do 0.189. That should be enough. Something ain't right. So I'm making this shaft really thick compared to the... It should be okay. Alright, let's see. Alright, we're gonna go 189 there. And then how much does it stick above? Oops, let's go ahead and measure this. Get a straight line distance. Come on. 0.0913. So we'll give that just a 0.1. That should be fine. I don't know why my graphics are doing that. I was doing that earlier today. There we go. That's good. And I think I'll chamfer that up there once I extrude this out. And we'll go ahead and go with the 1.25 as well. And then I'll... Hello, where'd you go? Do I want to chamfer on that, or do I want... fillet? We'll do a fillet. Let's see if that's too much. No, because I really want it to... I want it to lock into place. They'll probably deburr any sharps or anything like that, which is pretty standard in manufacturing. The tool that they use to cut this out will have a slight curve there, but it'll be smaller, generally smaller than what I would put if I put a dimension on there or a fillet. Then they would have to try and tool something for that purpose. So it's better to just do it this way, leave it, and then whatever tools they have that does it will do the trick. Alright, that part is done. And I can close this out. And what else can I close? I can close these out for now because I'm not really messing with them. Okay, some of them just don't look right. Oh, I know. Okay, what world's going on here? That's what's going on. Okay, that dimension I took earlier was not the right one. That's a little screwy. Huh. That don't make any sense. Okay, let's see what happened here. Did I do the wrong? Should be this edge here. Okay, what are we doing? This doesn't make any sense. Cordial. I know what I did wrong. I took that as the diameter and not the radius, so this needs to be times 2, but I'm gonna have to check the clearance. So the other one was 0.437 times 2, 0.874. So I really don't want it to be 1 inch in diameter, because that would be way too sloppy. So let's do 0.924. That doesn't give me much thickness there. And I don't know. That's really thin. I don't know if I may have to adjust something here. 0.038 of material. That's going to tear itself up. No, I don't want to save anything. Okay, I don't know why this keeps acting up. This is weird. Well, that's a lot bigger than I thought. Yeah, that's a pretty big difference. Okay, let's modify this a little bit here. 0.804. No, it wasn't 804. 874, that's right. 0.874. Let's try 0.9. Gives me a little more thickness. Yeah, I'd like to see even a little more, but I'm not going to get that out of here. What does that give me? What does that make this look like? It still looks really, really big. Just looks like a lot of slop. That is so much slop. I don't like it. Will this give me any meaningful information? No. Yeah, nothing. Okay. That's a Let's tighten it up a little bit more. Come on, really? Why is it not? I can still come in a lot more than that. Hopefully my graphics isn't acting up to where, because it doesn't look like it's showing what I'm doing here. Let me see if I can do a section through that. This plane. And let's flip that. Okay, that's that feature, which doesn't look like a solid because of the way the translation material. Okay, the way that between what the manufacturer sent me. All right, I'm gonna call that good because that looks pretty good. Let's see. What? What did I? Hold on. Did I leave? Oh my goodness. Did I leave that one in there? No. Oh my goodness. Stop doing this. No, it's not in there. So I wonder why it's asking that. That doesn't make any sense. We'll just save internally for now because I don't know why it's doing that. I didn't tell it to do anything. So weird. Okay, so that looks pretty good. Now, my only concern here is this assembly, how it's going to come together. Because there's nothing keeping these in place, left or right. And the way I have the shaft design, you know what, let's go ahead and go through this real quick. Let me save this. I want to do an exploded view. And the first step, oh, well, no, let's do this. Let's turn these air intake chambers. Turn those on. There we go. I also need to modify those, but that's going to be later on tonight. If we can get this shaft taken care of, that'll be my goal for tonight, to really make this look a lot nicer, and to accommodate for the exhaust that I'm going to need, all that good stuff. All right, let's see here. All right, let's start a new. Oops, insert. There it is. Exploded view. And let that catch up. Oops, my mouse is sliding off the pad. Alright, let's grab this guy. Oh. Wait, what? I only want... Why is it doing that? Okay, I have to go into the assembly here. Is it this one? Why is it... So, there we go. Select set of assembly parts. That's what I was missing. Alright, so we have that piece. And then I want that one's done. So the next thing that needs to happen is the shaft needs to come out. No. They would have to unbolt the motor and send that back. Okay. And then if I do this right, then this whole subassembly comes straight out with the bearings. So let's do that. That step is done. And then I need okay, this is going to be tricky. I'll need this bearing, this, excuse me. Did it select? Yeah, it selected that one. And the next one is this one. Then I need all of these and the shaft. Okay, and then that's going to come straight. Damn it, didn't grab everything. Why did I not grab everything? I thought I grabbed these as well. Okay, that's weird. That's the motor. And we're going to pull that straight up. That's done. And then if I did this right, this we're gonna slide out. And I'm doing this way because I want to make sure. Oh, damn it. No on that. That'll be a done step. And I want that piece to come out. Yeah, I have to do it this way. What just happened? Oh my goodness. Okay, that's done. And then this piece, that should slide right over the top of that. And it does. Okay, that's pretty much what I wanted to see so far. What I'll probably have to do then there's gotta be a way yeah, this is gonna be difficult because I see several design or several issues with this from when it's spinning. If there's no way that keeps these things, the spacing and all that stuff correct, then we're going to have a lot of freaking issues. Okay, that's okay. So I'm going to call that one done and call that done, just for now. Doing this because I can see issues with having this slide over here, but I really have nothing that keeps anything from wobbling. Now, my goal is to have this secured to the frame, or not the frame, but the air intake assembly, if you will, or housing. So I want it to secure here, but unless I add spacers, once these are secured in place, so I may have to modify the ring. What is this? Okay. I may have to modify that to keep these from bouncing left and right. So let me look at this. I wish there was an easy way to do this, because I've got those in set. So honestly, a spacer wouldn't be out of the question. And it would probably just be like a nylon spacer. Oh, no, that's not going to work. Because it has to slide onto the shaft. But it has to be able to be removed without sliding over the top of these, because it needs to be snug on the shaft itself. So what I'm thinking is, okay, all right, let's go ahead and collapse that. Just collapse that into place. And what I'm going to do then, actually I can delete that because that was just a quick tool. Alright, what I want to do is take one of these and one of those. Wait, let me make sure I'm grabbing the right thing. This one and this one. Yes. We're going to isolate that. And what I'm hoping I can do is sneak a dimension in here or something. Yeah, so I need this part. I need to open this up so I can see what it's doing here. Alright, so yeah. So I can take this part and that face and get a dimension on that. And I'm 0.25. 0.25. Let me mark that down. That's my spacing between the hubs. 0.25 inches. So let's look at, oh my goodness. Whoops. I'm going to do a new part. And I'm just going to call this a nylon spacer. Nylon spacer. Actually, I'm going to call it a nylon spacer half. And you'll see why in a minute. Alright, we'll do front plane. Yeah, I don't know why it's doing that. Do I have something going on here? The resource monitor says I'm fine. I don't have any updates. Oh, let me exit Steam. See if that helps any. What does this do? Okay, that's not what I want. Okay. It's still not. I don't understand why. I've got something goofy going on here. Anyway. Let me look at the shaft. And what is the diameter of this? 1 inch. So we're going to make this. Oops. That's so bad. 1 inch. And oh, you know what might even be better? Yeah. Let's okay. Yeah. 0.95 inches. That means I'm going to need to modify the shaft in relation to here. So let's bring the shaft back. Oh, okay, why is it doing that? Let's actually bring all of these back. And I'll show those components. Oh, wait a minute, let me get a better orientation here. Top down, that's fine. Okay, so from and so from this edge to the center point between these two, top plane, is that what I want? Yes, I do. Let's do a quick sketch here. Center line, I'm going to go here to there, and from here to here. So this is at the 2-inch mark. Okay, let me write this down so I don't forget. Two-inch mark. And then we're going to do the same thing down the line. Boom. From here to the midpoint. And then after that, 1.375, and that's going to be the same all the way down. And I need 1, 2, possibly 3. 1, 2, 3. Oh, possibly 4. I gotta see. Let me bring up the edge of the box here. Let's do the base. What? It's not what is it doing? That was weird. Let's view that. So actually, yeah, we'll do that here as well. Okay, all right. So I need to back this up a little bit from here to here. No, I need to go to the inside of that for this one. It's not going to give it to me. I'm going to have to come back and do that one a different way. So the in or the outs, I'll come back and do that a different way. That's what I'll do there. So for this instance, though, I will need the first one and 1, 2, 3 for sure after that. so that's what I'm going to do. Oops, let me go back to here, cancel this out because I don't need it anymore. I got my dimensions. Go to the shaft and get a top-down view. What's this? I can turn this off or hide it anyway. All right, so my first, let's see, let me see here. I got the right plane, that's fine. And do I have, should be able to do it this way, okay. No, I don't want it that way. Actually, I can just do it this way. Oh, no, I can't. Balls. Well, let's do this first, though. And I want this to be, did it from the inside there. So 2 inches. And I guess we can do this. Coincident there. Coincident there, that's fine. Actually, we will do it this way. .25 is my distance, so I want that to be dead nuts on. .25. That seems really big. Okay, what happened? Did I write something down wrong? Maybe it was supposed to be .025. Let's try this again. Goodness. Let's do it this way. Stationary. So let's just do this and this. This will give me a better. Okay. From here to here. Come on, I need a distance. 0.25. There's no way that's right. Hello? Edit. Why is that? I don't understand. That there's no way that's right. Because if I bring this down to cut it in the center, oh, maybe. It's right on that edge. This is really. may have to do a little bit of modification here. And then I want to go 0.05 down. If we take and do a revolved cut, no, I don't want it to be that. Here. I want it to be a this one. Let's see what that does. Okay. Okay, that's a little funky. We're gonna have to delete that feature for now. I'll have to come back to that. Yep. Because it's literally right on that. Okay, that's cool. That's actually pretty helpful. Alright, so I just need to do the same thing basically on the rest of these. Alright, so what I'm going to do is just mimic that same pattern. And we'll make sure that the features here are correct as far as the dimensions that I got. And from this one to this one should be 1.375. So it's going to be, okay, on each side there. So that's going to do the same thing here. But the distance might be a little bit different. I'll have to find out and see what that does. Oh. Midpoint. Actually, this would be the same as that. And this, oops. I can make this linear. Let's do it this way. We'll make these two equal. And then doing this all the way up. Hopefully you guys, this makes sense what I'm attempting to do here. If not, once I get the other part made, you should be able to see that pretty soon. Midpoint. This is the same size as this. And this is the same size as that. And one more here, and then this one will verify the dimensions in the model, in the assembly, to make sure that it's the same principle. If it is, great, I can just add the dimensions to this sketch and basically create it as all as one feature. So that'll be kind of nice. Let's see, center line. Oh, what am I doing? Goodness gracious. And midpoint. This would be the same as this one. This one will be, whoa, hello. Make those equal. Alright. So that solves that. I'm digging it. I'm guessing it's going to be the exact same because I think I did the same, excuse me, distance here. Let's do, let's bring this back and this is 0.1875 is the distance there. So that's going to require a different spacer, which is fine. I assumed it would. So that's what we'll design for. So we'll have two of these spacers. So this one is going to be, where is it? There it is. This will be the 1/2 inch, and then I'll have a, oh, what is that? 0.1875, is that 3/16? I can't remember. Yes, it is 3/16. So I'll have a 1/2 inch one and a 3/16 one. All right. So I'm going to go ahead and cut this in half. I really don't know why it's doing that. My apologies. All right, the 0.95. Oh, I screwed that up. Let's do this. Okay, we're still stuck in the trim command. The fuck? Make that a construction line. It was doing that to me earlier today. All right, so the diameter of my hub, we'll go with that diameter there is 1.75. Okay. Good Lord. Diameter is 1.75. And what I'll do now is connect this to here. And then we're going to trim out the excess. Boom. So far, so good. So it's got to stay underneath that. So this is my shaft. Okay, I'm going to put a marker in here for the shaft diameter of the, well, yeah, for the shaft itself, which is 1 inch. And that's going to be my no break point. And you'll see what I mean in a second here. And then I want to do, we're going to do an extrusion. And I'm going to do this mid-plane, so I have the central plane splitting this evenly. And that's going to be my, this one's going to be my my 1/2 inch, or 1/4 inch one, sorry. I think I keep saying 1/2 inch. And we're going to make this material as nylon. Should be plastics. Nylon 101 sounds pretty. Come on, apply and close. That's weird. I'm going to save it and then I'm going to rename it here. Actually, I could make it a configuration. Yeah, actually, I'm going to do that. Come on. There we go. 0.25 inch. And then the next one will be the 0.1875 inch as well. Since I've got to go 0.1875, 4 spaces, I will put this as 4 spaces as well, so it has some, it maintains some integrity. I'm really surprised that the nylon 101 has that color appearance. Interesting. I wonder. Huh. What does nylon 610 look like? looks like a clear plastic. I think that looks cooler. We'll go with that. I'll figure out. This will have to be basically I'll have to verify with manufacturers, giving them application and finding out from them best what material would be best used in this application, because they could spin. There could be, but the friction may cause them to melt depending on their material properties. So that would be something I would get with a manufacturer to say, okay, this is what I was thinking. What would be the material I would need for this type of application? And then they can say, oh, well, you need this, or no, what you selected was fine. So we'll have to keep that in mind. And I'm going to go ahead and chamfer these edges here. Let's do 1/16. Let's see what that looks like. Oh, that's too much. Yeah, that's fine. All right, now, where is my no-go zone? That's there, so I should be just fine. So I wonder what size I would need for that. Actually, this would rotate with the shaft. By the way, I'm building it. I might need a top and a bottom. Let me see if I can make this. How can I do this? Because I believe if okay, I might have to do this in a couple different parts this way. Yeah, let's do it like, oh, you know what? I want to show that. That way I can get an idea of where. No, let's do it this way. Let's go with the hole feature. And I should be able to do a threaded hole, or sorry, a through hole. Where it can screw and nut configuration. Maybe. Alright, let's see. Okay. What? Why is it doing tap drill? What is this one then? That's weird. I'll do a screw clearance, and I'm thinking I might need like a number 4. Let's see what that looks like here. Yeah, that's what I'm thinking. Let's do a center line from here to the edge, but I want this to mate the intersection of that. No, that didn't work. It edge. Okay, that doesn't make sense. Can I do it this way? It's still not. What? Pierce? There, that's what I want. Okay, jeebs. That way I can get a... Do the same thing over here. From here. And then I'll take this point and pierce it again. There we go. That gives me a center line without having to do a whole bunch of measurements. Alright, back to putting this here. Let's do it's centered. Oops. And why is it? Oh, I need to. Okay. I need to verify where that picked that center up. Okay, let's turn this off. There we go. Alright. Now I want that through all. And I almost want it to be counterbore, but side opposite, I believe. Whoa, hello. Wow, what the hell's going on here? Oh, I'm going to have to do, because it'll think, okay. I'll have to do this in stages, in pieces. Just fine. Okay, so let's go through all. Alrighty. And then what I should be able to do, I'm going to try it one way first. Actually, no, I'm going to do it. Let me try it this way here. We're going to do, yes, from the top plane, I'm going to do a plane from there, and I want it to be, ooh, is that going to work? I need it to be tangent to this. That's not going to do it. What is, let's see here. Can I do, what does that do? Yeah, it doesn't like that. Parallel, maybe? No. Distance? Coincident with, I don't want the edge. I want the, what? No. Delete that. Nah, it's not liking that at all. Okay. Let's see, what's the... let's see, can I get from here? Let's just see what happens, what dimension it gives to me. Okay, that gives me the shortest point, 0.449. Okay, alright, I can work with that. 0.449. Let's go ahead and grab that. And we'll do the same thing that I was going to try and do, but we'll cheat it a little bit here. Okay, now and number 4 set screws, so I'm going to have to look up what the dimensions are. Let's see, not a set screw. It was the other one I talked about. Fudge. I'll just look at the toolbox here. Bolts and screws. I think it's machine screws. No. Honestly, that would be fine. I can do a pan crosshead. Wish I had my machinery's Bible with me, my machinery's handbook. Let's see. Number 4. Panhead screw dimensions. I just want the head. Panhead. I want the A diameter between 205 and 219, so we'll make it the 219. Okay. Hopefully that's 219. That's going to be really close to the outer. Oh, I want these to be the same. Equal. Diameter of 219. Yeah, that's going to cut into the chamfer, which I can modify that later. And then we're going to do an extruded cut. Direction 1, I want it to go, yeah, that's deep enough. And then direction 2, I want it to go through all. That way it makes sure it cuts all the way up. So far, so good. Now, what I need to look at is the nut on the other side. So, okay, so what this is going to have to be is the top. I'm going to have a top and a bottom. So the top is going to have this feature, and the bottom will have a smaller diameter hole as the receiving, and what I'll use is a self-cutting screw so that it draws them both in. Kind of like a tech screw if you've ever done sheet metal. If you haven't, don't worry about it, it's fine. Alright, so that's the top. Alright, so actually what I'm going to do is modify this. Top. And then we're going to make a bottom one. So I'm going to do add configuration 0.2500 inch bottom. And then we're going to go into here and remove these features, suppress them in this. But I do want to see that so I can utilize the same. And no, if it's suppressed, it won't do it. That's fine. I'll I'll bring this information back and I can utilize it since I know what I did. Alright, and the bottom is going to be basically the same thing but with a smaller diameter hole. So looking at the I need the pitch diameter though. Let's see, can I... Is it the pitch diameter that I need? Let's see what this says. Oh, that's not going to give me. Okay, number, whoops, 440, thread dimensions, that's what I want. I need minor diameter. Here we go. This is what I want. 440 right there. Whoops. Minor diameter for the 440 is 0.08, 0.09. I'm going to take the lowest one. And we'll match that to the next available drill size. 0.0849, 0.849. Alright, let's see what SolidWorks has in the toolbox here. First of all, I'm going to do a sketch. And we're going to do the same thing like we did on the other one. Go from here, stop some arbitrary point, and then pierce it to that segment, or that circle. And same with this side, so I get my midpoints. Pierce, okay. And then we're going to turn that back off. Oh, I did this wrong. I'm supposed to do this in the, my apologies. I need to do this in the hole feature. Let's try this again, shall we? Hole feature. I don't want screw clearances. I want all drill sizes. And I want to show the decimal value. And I'm looking at 0.0849 is my ID. Ooh, that's really tiny. 0.0849 is in between 82, so we'll do a number 44 drill there. 0.08 sits. It's a little bit bigger, but it's still under the max that can be, so I know I'm going to have enough grip to get that. In condition through all, no, I don't want it through all. We'll go, yeah, we'll go with the recommended depth there. Alright, and then now I'm going to do the scale. Oh, yeah, on this plane. There we go. Let's bring that back, and we're going to do our sketches real quick, then we'll put those pieces in there. Come on. What? Oh, there they are. Oh my goodness, that was weird. Pierce. Alright, then we'll hide these. Oh, for Pete's sake, there it is. Yeah, my graphics is acting really strange. I don't understand why. That should be enough. Okay. Alright. That one's done. And then we're going to make a thinner one with the 3/16 size. I'm hoping with the screw that I grabbed, you know, I'm going to remove the chamfer out because that's just not going to, I'll have to see what they recommend because that's just not going to work. All right, so let's go back to the top and make sure just the one goes in there. Yes, perfect. And we're going to do another configuration, make it 0.1875 inch top. I believe that's how I did the naming convention. Yes. And the only thing I should have to do is give this an extrusion, 0.1875, and we'll give this, okay, that's what I was afraid of, because that means the head of the screw is going to bulge out and interfere with the thickness. So I'm going to have to change this information here. So let's do this. I think I'm going to have to make this a number 2. It's really crazy. I don't like it. And what I might have to do, does that mean I'm going to have to bring it all back? So that means this, no. These will be suppressed. And I'm going to have to initiate a new one here for just this one. Or, well, I'll have to do the same thing on the other part there. Okay, so we want a screw clearance. And we're going to try a number 2. Let's see, let me get to, what's the number 2 panhead? There's number 4. Whoops. Number 2. Hopefully they have them that small. Yeah, they do. I just need that same chart because that was really easy to look at and go with. This one has G. Nominal screws. Oh, it only goes to 4. I need a number 2, man. Slotted Phillips, A. Number 2, A. 167, 156. So we'll go with 0.167. Here we go. That'll be on the counter bore, 0.167. Okay, that'll be through all. Let's see. I need position on this plane, and I want to sketch out my lines. Oh, nope. Gonna hide this. Put our PC parts in. Okay. That should be that. Okay. And then I want a sketch here. Those are going to be equal. Whoops, dimension that. 0.167. Oops. Ooh, that's going to be really thin. I don't care. extrude that down. We'll go with 0.25, and then direction 2 we'll go through all. Good. Yeah, it's a little thin, but it's going to have a, should be fine. That should be fine. Okay, that's the top. And then I'm going to add a configuration, 0.1875, bottom. Oh, nope, inch bottom. All right, after I finish this, we'll do a little break here. Where am I at? Ah, bottom. Bottom is going to get rid of these, suppress those, and I need the number 2. Let's see, number 2, I need the minor diameter. Here we go. Number 2, 256. That's the one I want. 2B is fine. 0.0667. Let's see what the next thread size in for that is. This one. Any day. Hello. Can we? Thank you. Aw, punk. Teasing me. Okay, there we go. I'm gonna do a save on this in case something crashes because my computer's acting really silly right now. Okay, I don't need this on anymore. Feature. Oh, Jesus. Gotta pick the right drill sizes. Show decimal values. 0.0. What do we got? 667. Too far. Alright, number 51 it is. Position's going to be on this plan here. And then, let me turn this back on so I can see it. Pierce. Turn that back off. Center. Center. And I do not want to go through all of the blind. 0.37 is fine, I'm guessing. Boom. Alright, just do a quick run through, make sure everything turns on and off the way it's supposed to. I know what happened. I did not specify that thickness to be specify configurations, cancel, specify configurations, this one and this one, okay. Regenerate that. Perfect. Boom. Boom. Excellent. Okay. 0.1875. So we need to go back to the shaft, which means that this feature, actually I can do, I can add this to this. So it's going to be butt up against there. I'm going to do these a little bit different to see if it works. 575. Zero five, and then we'll have the same thing here. Wait a minute, I need that. Oh, I probably need to verify that I did that on the other one. Come on. Yeah, let me look at this here. Because this, I think, is goofed. Yep. Get rid of that. That to there. There we go. Now we're cooking. Okay, so I'm liking this so far. Alright, I'm going to exit the isolate, and then what I'm going to do, actually, we're going to take a break. Take a quick break, save this, and I'll be back in a few minutes. Stretch the legs, use the restroom, and I'll be right back. Alright, I'm back. Thanks for sticking with me. Alright, so what I'm going to do here is... Actually, I'm just going to isolate the shaft. And then I can put these pieces in here. And then we'll check and make sure that I did it right. Alright, so we're going to go to the assembly feature and insert components. And I'm going to put these nylon spacers in there. Now, I can... Okay, the 1875, that's good for the top. And let's rotate this in a G. Take that, made it to that. Alright. And then I should be able to just mate this to here. And then I'll take this part, duplicate it, and then change the or the configuration to bottom. And then do this. Hello. Centric made it to that. Pull in there. Made that. No. Nope. Come on. Nope. Oh my goodness. It does not want to grab what I want it to grab. Then we'll make those two together. And then what I'll go ahead and do to keep it from spinning, or it'll spin with the shaft basically. All I have to do is select one of these. Do this. And we'll mate it to the front plane there. Boom. There. Now that should, yeah, it spins with that just fine. Oops. Now I want it to, there we go. Alright, and I just do the same thing all the way down the line. Do that there. Duplicate that one. Duplicate this one. And then I'll duplicate them again and mate them to the, with the bigger size, made them to the shaft, the larger size. Boom. Boom. This piece connected to here. And same with this one. Let's grab the right part. Make that. Okay. And then we'll do the same thing. Let's do this. Okay, I need that to move out of the way so I can see what I'm doing here. And right plane to front plane mate. No, that's not right. What? Let's undo that. Let's try that again. Top plane. There we go. Grab this, grab. Hello. Can I have it, please? Thank you. Change this one to the 1/4 inch. Oops. There we go. Same with this bad boy. Stop. For Pete's sake. that. And I could actually, no, I can't use nylon screws with that. I would have to use actual screws. Oh, made that one. Boom. Top plane to front plane. Okay. Do that a couple more times. This makes me a lot. This gives me the warm fuzzies. Make sure that these things are going to keep spaced. And assembly and disassembly would be relatively easy for servicing. And it's possible that this may need to change a little depending on friction and how it behaves. So we'll have to see how that plays out in the future. Oh, for Pete's sake. Really does not like this see-through material very well. Alright. 7. Top plane to front plane. There we go. Now you know why I put the groove in the shaft itself. That way these can actually be pulled out independent of sliding these out. Oh. Actually, no. Shit. I may have to change the hub. Because you won't be able to get to those. Might be able to get to the end one. Disassemble, slide, then disassemble, slide, disassemble. That might work. I'll have to. This may not work the way I thought it would. I may have to modify this a little bit. We'll have to see. Top to front. One more. Come on. Exit isolate. Oh, goodness, why does it do this? Oh yeah, you can get to that one and slide off. Then you'd have free access to the next one. Yeah, that works. That works. No worries there. Yeah, that looks pretty bad, eh? Why is it trying to get the... Excellent. Okay, yeah, that looks good. Collapse all. Collapse, there we go. Alright, let's save that. Well, the cool thing is I can basically take everything that I've done and basically mirror it over when I'm ready. I'm just not ready yet. Okay. That pretty much takes care of the shaft. I think we got it. Now to figure out how I want to do what I'll probably have to have happen here. Just thinking ahead for the mounting. Okay, honestly, I can. Oh, man, that would be kind of cool. All right. I think it's time for me to look at the chambers because I do need to extrude a little bit more material, or sorry, remove a little bit more material. What do we got here? That is that, because I need to have it be a little bit bigger. So let's do 8.065. Save that. And that'll give me that'll give me a nice little gap there. What did I do? I did that one. Just let me do this one. Oh, wait. Ah, damn it. I did the wrong dimension. Cram Nedley. Bottom. Yeah, that needs to be. .065. Wonder why nothing looked different. Go chamber top. Come on. Yeah, there we go. That modified it everywhere. Whoops. Now, let's check this out here. Let's section through. Yeah, that's good. Let's Just make sure we've got enough materials. Oh, you know, let me take that off of that. And let's look at... Oh, thank you. Okay, it was just taking its time. Alright, so basically I've given us a little bit more clearance in between there and there. I didn't want much. Should be like a 32nd of an inch. So that should reduce any chances of this rubbing up against the outer wall. What that does do is complicate the... Oh. That prevents me from doing... So it should be slip here, tight against the next set. Okay, that's gonna be different. Let's undo that. So I'm actually gonna have to do something a little bit different than what I had originally planned. Let's look through that. Because basically I need to have two bands to where it just basically smashes those into place. And if I'm going to do that, then I'm pretty sure I'm going to have to modify and put the same type of bearing in there. Pretty sure. So that means I'm going to have to go in and find a bearing, because I got this one from MasterCar. I wonder if I have the other bearing in there. I think I downloaded a bearing that didn't have the that little hat on it. Let me see here if I have. That's that one. Let's look in my components. No, I think that's the same ball bearing. It's already open. Do you want to show that's already open? No. So we're just going to ignore that happened. Yeah, I am going to have to do that. So I think what that means then is I'm going to have to get some dimensions here. Let me... Alright, from here to here, I think it is 1.5 inches. Is that right? 1.25 inches. Let me turn this off for a second. And let me get this dimension. Actually, no, I need... Boom, boom, boom. Let's isolate those. Isolate. Perfect. Now I can go from the inside, and it'll be the exact same between the two. From here to here is 1.5 inches. Okay. So we got 1.5 and then 1.25. And then that should be pretty much the same here too. Oops. Yeah. And then 1.5 and 1.25. And what I think I'll do is I'll add the material back in. That'll be faster than going back through and doing other things. Alright, so top. This is the airflow chamber base. Whoa, hello. And I want that to be, I can do it on this plane. Put a sketch in there. Oh, whoops. I accidentally hit edit sketch instead of new sketch. There we go. Alright, so I want this to be like this so. And that like so. And then we'll go with this. 1.5 inches. Really 1.25 inches. This is going to be the same as this. Alright, now all I need is to get center line, infinite length, horizontal. Boom. And then from here to here, that's going to be 9 inches. Yep, I knew it was going to be really tiny. That, stop it. That's going to be collinear. And then I'm going to revolve that. No, I want to revolve. There we go. And I don't want it to be a full 360. I want it to be 180. And the direction to be reversed. So basically I'm just adding that strip of material. And what that's going to do is, instead of me putting holes and securing it to the base, I'm telling it, I'm making it a friction deal. Basically hold those in place, and then when I put the new bearing in the stationary shaft, or the stationary hub, the shaft will rotate and there will be no wobble bobble while it still maintains and holds tight to that surface. So basically kind of like how drum brakes work in a car. They have your drum, it's a cylinder, and then they have the brake pads, and when you press on the brake, it expands out and it provides friction to the inside of that plate, thereby slowing the car down. This is basically the same principle. That looks good. And then what I'll do is I'll mirror that there. Features, mirror, done. And then I need to do the same thing to the top. Wait, what? Why did it do that? Okay, that's a little odd, but whatever. Do a new sketch there. Oops. Center line, infinite length, horizontal. Boom. Whoops. I want this and this collinear. I want this and this to also be equal. And throw the dimensions in. 5, 2.5, 5, here to here, and 9-inch diameter. 12. Let's see, 1/2 of that, and it to be the other half. Boom. Then I want that and that. Mirror on the wall. There it is. That's the one I want. Alright, we can save that. And then we can go into our deal, do an update. Stripes are in there. And that's going to rub right up against that. So that's exactly what I want. We'll exit the isolate on that. Oof, good grief, this thing. There we go. Do a save on that. Well, this feature, the getting the shaft done, is as I'm going through and making sure I'm accommodating for everything that I need. I might not get to the housing as I was hoping. Then again, I might. Let's see. I'm at. Chill's trying to make a look at my gun. Okay. I'm kind of at the limit I've been generally keeping, but I think I want to finish at least the shaft, and then I could. The housing is probably going to take some extensive rework. So, yeah, we'll finish the shaft out. Alright, let's see. I want stationary, and I want the stationary hub. So, what that's going to do, that hub, the bearing's going to have to slide over. Okay, I can't put a bearing in there. Not going to be able to put a bearing in there. Because then I won't be able to slide it over. I may be able to do another nylon configuration like I did, so that it basically fills the void and is kind of pressed in there. Man, this sucks. Because when I was doing this, I thought I may have to make the stationaries two pieces. I really don't want to do that though. Let me look at this again. Let's go with the stationary, and shaft. Let me isolate those bad boys real quick and just see what we got here. I don't think I'm going to have a choice but to leave it like that. I mean, it's free. And if everything is made concentric the way I have it here, that shaft is not going to wobble. This is going to get held into place. So I think I'm going to leave it like that. I don't think I need to overcomplicate it any more than I already have. Yeah, I think that works. I think that's what we'll do. So that actually wraps it up for the shaft. I've got the... Oh, wait a minute. Is that going to work? You know, these might need to be a little bit bigger to overlap the gap, or overlap the... Because I don't have the fill. What's this diameter? Because I thinking I'm gonna have to make those the same diameter as that. 2.125. Yeah, let me go ahead and do that real quick. And that'll be the 1875 ones. Let's do the bottom first. That inside diameter is fine, just the outside diameter is going to need to be modified. Shit, what did I say? So I'm okay with that dimension there. I think I said 2.125? Yeah, 2.125. Specify configuration. Oh, damn it, I gotta do this first. 125. And specify the configuration. These two. Make it okay. That's good. Let's rebuild it. And let's look and make sure that that did what it's supposed to. Alright, I'm okay with that. That was my first one, so I'm going to leave that as my default. And save that. And then let's look at that again in the assembly here. Yeah, I'm much happier with that. That makes sure it doesn't bump me, so slide inside to that. Even though the inside rim would prevent it, this just makes me feel better. There's you know, 2 points of contact there. Now, what I might have to do is provide a little bit of like a pocket on the interior, a certain diameter, shave it in just a little bit so that it free spins. So it'll be locked to the shaft. Well, no. Probably would have to have, the shaft is fine, but this between here and here, I would probably have to do a little shave on that just to make sure that it doesn't rub up against there. Same with this one. It can hit this just fine, but it needs to be free from this other side. I'll have to play with that. Or and nylon, it may be. We'll have to see. It's going to be tricky doing that. So, and I think I'm going to go ahead and end it here. We got a lot done. I'm really happy with the shaft. And we'll go ahead, and I did do some modifications to the airflow chambers, the top and bottom of them both. And so that's something. And next episode will be a pretty much a full modification of the container, the airflow container. I'm going to make sure to get in the inlet, get my outlets looked at, and put in. And I believe what I'll also do is have this feature, the bottom, accommodate mounting for the motor itself. So it's all one piece. So we'll see how that goes. So, yeah, we'll do it that way. All right. Yep, that's it for tonight. I thank everybody for dropping by. It's been great. I'll catch you all next week. Thank you so much for watching. I appreciate it.